Good morning, students. I'll share my this PPT. Just okay. The second assignment in hydrology and water resource engineering, that is making catchment area on a topo sheet and working out average annual precipitation and determination yield by various methods. So this is the assignment, second assignment of hydrology and water resource engineering. So the catchment example that I have shown here. This is the catchment boundary, and this line that is shown here, that is a stream. And along this stream, if you consider any point as an outlet, you can delineate a catchment for that outlet. Catchment means whatever the rainfall that is occurring in this area will join this stream, and all the rainfall and runoff that will flow through this stream, and it will come out from this outlet. This is the concept of the catchment. This catchment boundary, this is nothing but a ridge line. Ridge line, that is in contour. You have studied the ridge line and valley line. As an example, I have given the contours shown here, the contours like this. I have shown the valley line and ridge line. Valley line and ridge line contour lines are shown. Now if you see, this is shown with the red dash line over here, that is a valley line. That is a valley line. Valley line means the water flows along the valley line. Water flows along the valley line from higher elevation to lower elevation due to gravity. And the ridge line, if you consider the ridge line, the water flows perpendicular to the ridge line. Water flows whenever the rainfall takes place on this ridge line, the water will flow perpendicular to the ridge line, and all the water will get collected in this valley line, and it will flow along the valley line. So all the streams or rivers are along the valley lines. All along the valley lines are, this is also called the streamline. Valley line are also called the streamline. So in this features, that is valley line and ridge line, these features are very important. And the boundary of the catchment is a ridge line. Whatever the rainfall occurs on this ridge line, this flows towards this valley line. The overland flow takes place from ridge line to valley line, and thereafter it flows along the valley line and it comes out from the outlet. So that is the concept of this catchment. So on the topo sheet, the valley lines are marked. Valley lines are, those are also called the streamlines. Streamlines are marked, and on the topo sheet you have to mark the ridge line. You have to mark the ridge line. You have to mark the catchment boundary. First, you have to consider the outlet point along the streamline. You have to consider the outlet point along the streamline, and you have to delineate the ridge line, and you have to mark the boundary of the catchment. That I will show you in the next slide. Here it is shown. So here as an example, I have shown here the streamlines. This is a streamline, major stream flowing. This is another major stream that is flowing. Here one more major stream that is flowing, and these are the branches of the stream, isn't it? These branches are joining and they are becoming bigger and bigger, and this is the major streamline. These streamlines are also called the valley lines. Now if you see these smaller streamlines or these smaller branches, these are joining this main stream. And if you consider these branches over here, these branches are joining this stream. So there is a ridge line in between. So this red line, this outlet is given. This is a streamline that is given to you, and if suppose this is the outlet that you are considering on the streamline, now you have to mark the ridge line. Means you have to separate the streamlines. This streamline is starting from this point, and this the adjacent streamline is flowing in this direction and joining the other stream. So there will be a ridge line in between. So this red line, this is passing in between these streamlines, because whatever the streamlines over here, these are joining this stream, and these streamlines are joining this. So there has to be a ridge line in between. So ridge line is drawn like this, and this here also, these branches are of this major stream. So this way you have to delineate the catchment on the toposit. So this toposit you have to see the streamlines very carefully, and you have to draw it. So here the image of the toposit, just it is shown over here. The example that the earlier student that have done, the outline was given here. Outlet was given along the stream at one point, and it was delineated like this. That is this black line that you see over here. This is the boundary of the catchment that is delineated on the toposit like this. You have to see the streamlines here. The streamlines and all other lines are mixing, so there is slightly difficulty in understanding that one. So this streamlines shown with the black color, and you have to separate it like this, and you have to delineate. The first step that you have to delineate the catchment. So once you delineate the catchment like this, then you have to consider the rain gauge stations along this catchment as A, B, C, D, E, F, G, H up to Q. Rain gauge stations, those you have to consider at different locations. Rain gauge stations you have to consider at different locations, and the rainfall record. So consider, suppose this is the catchment boundary that is delineated, and this A, B, C, D, E up to Q, these are the rain gauge stations. A, B, C, D, E, F, G up to Q. These are the rain gauge stations in that catchment area considered. And this record is also given. This is the given data for A rain gauge station, this rainfall that is recorded. For B rain gauge station, the record is given. So for all rain gauge stations, the rainfall occur during any specified period. If you have to find out the mean precipitation over the catchment, then there are methods: arithmetic mean method, Thyssen polygon method, and isoheitel method. These different methods are there which are used to find out the average precipitation over the catchment. Average precipitation over the catchment. That if you see here, A, B, C, D, these rain gauge stations are recording different record because the rainfall is not uniform for the full catchment. Catchment area may be very big. So the rainfall record for each rain gauge station is different. But if you have to find out the average rainfall over the catchment, then there are three methods. Just I will explain you the three methods. Those are over here. The first one is arithmetic mean method. Arithmetic mean method, that is just you have to add the records and you have to divide by number of records. That is arithmetic mean method. Arithmetic mean method, that is in mathematics, just as you are finding out the mean of many records, the similar way you can find out the records, the average. That is first method. Second method is Thyssen polygon method. Thyssen polygon method, that is shown over here. That is, these are the rain gauge stations. Those are shown over here. Different rain gauge stations shown over here. You have to join these rain gauge stations. You have to join these rain gauge stations, and you have to bisect these rain gauge stations, and you have to divide the area in polygons. You have to divide the area in polygons. So the polygons are shown with the red color. This 1, 2, 3, 4, these are the rain gauge stations that you have to join. These are joined by this blue color line, and these red lines are the perpendicular bisectors. Red lines are the perpendicular bisectors, and the area is divided in polygons. Area is divided in polygons. Now this is one rain gauge station that I am showing with the cursor. For this rain gauge station, this area is considered. This polygon is considered for this rain gauge station. Now this is the another rain gauge station. For this rain gauge station, this is the second polygon. For third rain gauge station, this is the third polygon. This is the fourth rain gauge station, fourth polygon. Like this, Whatever, for each rain gauge station you can get one polygon like this, and you have to find out the mean precipitation. Mean precipitation that you have to find out as A1 P1. A1 is area for the first rain gauge station. P1 is the precipitation that is recorded for the first rain gauge station. A1, the subscripts show the number of the rain gauge station. First rain gauge station, second, third, like this. There may be n rain gauge stations. So summation AP at the numerator and summation A at the denominator. With this you can get the average precipitation over the area. This Thyssen polygon method is more accurate than the arithmetic mean method. In arithmetic mean, just you are adding all the records and divide by number of records. So that is arithmetic mean method. That is simple method of finding out mean precipitation over the catchment. Mean precipitation over the catchment. So this Thyssen polygon means for each rain gauge station, a polygon is assigned. By drawing a polygon graphically, means it is considered that whatever the rainfall recorded by this rain gauge station, that rainfall will occur in this area only, and whatever the rainfall that is recorded by this rain gauge station will occur in this polygon. That is the assumption that is made. Whatever the record that is recorded by this rain gauge station will occur in this polygon. This way it is considered, and the average precipitation is calculated. That is summation AP divided by summation A. That is the mean precipitation. And the third method is isoheightal method. Isoheightal method wherein isoheights are drawn. Isoheights means the line joining equal rainfall. Line joining equal rainfall, such lines are drawn as you are drawing the contour lines. Contour line is the line joining points of equal elevation. Similarly, isoheights means line joining points of equal rainfall. And area between the consecutive, that I am showing here by the cursor, area between the two consecutive isoheights, this is measured, and it is multiplied by the average precipitation. This may be P1, this is P2, isoheight of P1, isoheight of P2, the average isoheightal record that is taken, that is P1 plus P2 by 2 into this area. This is taken at the numerator and divided by the total area, that you get the average precipitation by isoheightal method. So these are the different methods of finding average rainfall over the catchment: arithmetic mean method, Thyssen polygon method, and the isoheightal method, arithmetic mean method, and Thyssen polygon method. In this assignment, you will be finding by the isoheightal method. Isoheightal method, that is A, B, C, D, that whatever the rain gauge stations given, you have to join those rain gauge stations. You have to then whatever the line joining the two rain gauge stations, that you have to bisect by using the compass box. You have to draw a perpendicular bisectors for all these lines, and for each rain gauge stations you have to delineate a polygon. You have to delineate a polygon, and the areas for each rain gauge stations that you have to assign, and that are written over here. That will be the next column. These are the rain gauge stations named as A, B, C, D up to Q, and these are the precipitation records. Those are given for these rain gauge stations. That is, A rain gauge station recorded 102.3. Likewise, all the records of the rain gauge stations, those are given over here. Thereafter, you have to assign a polygon for each rain gauge station by joining the rain gauge stations and drawing a perpendicular bisector to these lines and getting a polygon, isn't it? So likewise, and then you have to find out the area for each polygon. Thereafter, this is area into P. Multiplication of these two columns, that is the next column over here, that is written over here. And here the summations, summation of area and summation of A into P or P into A, that those summations also you have to calculate. Then the average precipitation will be that, as it is told in this, summation PA or summation AP divided by summation A. So this way you have to find out the average precipitation over the catchment. Average, so this is the average precipitation, 109.98. This is the average precipitation that is calculated by Thiessen polygon method. Now if you see, the records are 102, 101, and also it is the maximum is 121, and the average that you are getting is 109 or 109.98. This is the average rainfall that is occurring, and then the yield will be equals to, yield of this will be equals to this average precipitation multiplied by the area of the catchment, multiplied by the area of the catchment. So that is summation A, that is summation A. This way you have to find out the yield of from the catchment, that is how much volume of water that will be there for this catchment, for this rainfall record. So this is the second assignment in your hydrology and water resource engineering. Just I will just in, so this is the second assignment that has been told, that is the marking of a catchment area on a topo sheet and working out average precipitation and determining the yield by various methods. So that is the heading of your assignment. So that I have told you, that is delineation of catchment, that I have told you how to delineate the catchment on a topo sheet, that I have told you, that is like this. Whatever the streamlines are there, you have to separate out streamlines joining the other major stream, you have to take to one side, and whatever the streamlines joining to our considered mainstream, those you have to enclose like this. You have to first, you have to consider outlet and delineate the catchment. This you have to do on the topo sheet, and by tracing paper you have to trace it on the tracing paper, and on this tracing paper you have to consider any number of rain gauge stations. Here they are considered from A to Q. So many rain gauge stations are considered. This is as an example, it is shown over here. That is example of a catchment. This is considered, and A to Q rain gauge stations are considered, and by Thiessen polygon method, for each a rain gauge station, a polygon is delineated, and the area of each polygon, that is also written. Then summation of, then this P into A, that is the next column, that is area multiplied by precipitation, that is this next column. Again you have to find out here the summation of area as well as summation of PA, and this you have to use for finding out the average precipitation over the catchment. The precipitation over the catchment will not be uniform, it is varying, but for analysis purpose you have to find out the average precipitation over the catchment. Thank you very much.